In this video, I will be focusing on the mean value theorem. And the definition of the mean value theorem states that if f of x is defined and continuous on the interval a and b, and differentiable on the interval a and b, then there is at least one number c in the interval ab such that f prime of c is equal to f of b minus f of a over b minus a. And we have an example here. Let a and b be real numbers such that 0 is less than a less than b. Prove that b minus a over 1 plus b squared is less than tan inverse b minus tan inverse a less than b minus 1 over a squared. So here we have 0 is less than a less than b. We also know that f is continuous on a, b, and differentiable on a, b. Hence, by MVT, there exists a c in AB such that f prime of c is equal to tan inverse b minus tan inverse a over b minus a. Now we have f prime of c is equal to 1 over 1 plus c squared, which is just the differential of tan inverse of c. So this implies that our f prime of c is equal to 1 over 1 plus c squared is equal to tan inverse b minus tan inverse a over b minus a. Now since a is less than c less than b, we have a squared is less than c squared less than b squared. Also, we have a squared plus 1 is less than c squared plus 1 is less than b squared plus 1. It follows that 1 over a squared plus 1 greater than 1 over c squared plus 1 greater than 1 over b squared plus 1. Where we have our 1 over c squared, or 1 over c squared, is just our tan inverse b minus tan inverse a over b minus a. So we can go ahead and write this as 1 over a squared plus 1 tan inverse b over minus tan inverse a over b minus a is 1 over b squared plus 1. And if we go ahead and multiply by our b minus a, we have b minus a over a squared plus 1 is greater than tan inverse b minus tan inverse a greater than b minus a over b squared plus 1. And there we have it. We can also rewrite this as b minus a over b squared plus 1 is less than tan inverse b minus tan inverse a less than b minus a over a squared plus, and that's it for example 1. Now on to example 2. Given f of x is equal to sine x for x is in R plus, use MVT to prove that sine x is less than x. Now first we want to establish our interval, and since x is in R plus, then our interval is 0, x. Now, by definition, our f prime of c is equal to f of b minus f of a over b minus a, where the 0 is our a and the x is our b. So our f prime of c is equal to sine b, which is just sine x, minus sine 0, which is just 0, over x minus 0, which is just x. So we have sine x over x. And differentiating our function, we have f prime at x is equal to cos x, which implies our f prime of c would be equal to cos c. Now for c in the interval 0x, we have 0 greater than c greater than or x, implying our cos 0 is greater than cos c is greater than cos x. Now our cos 0 is just 1, so we have 1 is greater than cos c. Our cos c is just f prime of c is equal to cos c, which is the same thing as our sine x over x. So we can just write sine x over x is greater than cos x. And multiplying through by x, we have x is greater than sine x greater than cos x. And here we see that our sine x is less than x. Now for example 3, we have given f of x is equal to tan inverse x for x greater than 1. Use MVT to prove that tan inverse x is less than pi over 4 plus x minus 1 over 2. So first, f of x is continuous on 1x and differentiable on 1x. Now f prime of x is equal to 1 over 1 plus x squared, implying for c in the interval 1x, we have f prime of c is equal to 1 over 1 plus c squared. And by MVT, there exists a c in the interval 1x such that our f prime of c is equal to f of x minus f of 1 over x minus 1 equal our tan inverse x is just tan inverse x minus tan inverse 1 is just pi over 4 over x minus 1. Therefore, it implies that for c in 1x, we have 1 over 1 plus c squared is equal to tan inverse x minus pi over 4 over x minus 1. And for the interval 1 is less than c is less than x, we have square. Let's square each term. We have 1 squared is just 1, c squared less than x squared. And if we had 1, we have 1 plus 1 is just 2 is less than c squared plus 1 is less than x squared plus 1. And if we decide that we want to put 1 over each of these, we have 1 over 2 is greater than 1 over c squared plus 1 is greater than 1 over x squared plus 1. And notice that here was 1 over c squared plus 1 is just our f prime of c, which is tan inverse x minus pi over 4 over x minus 1. So we can rewrite this as 1 over 2 is greater than, or tan inverse x minus pi over 4 over x minus 1 is greater than 1 over x squared plus 1. And doing a bit of transposition, we can see that we have x minus 1 over 2 is greater than tan inverse x minus pi over 4 is greater than x minus 1 over x squared plus 1, implying our tan inverse of x is less than pi over 4 plus x minus 1 over 2. And this is our final answer. So by MVT, we have proven that if f of x is equal to tan inverse x for x greater than 1, then tan inverse x is less than pi over 4 plus x minus 1 over 2.